Hey-oh, I'm just getting into some function notation. This is going to be super basic, so just an introduction, just in case you forgot, or in case this is the first time you've seen it. Function notation. So you've dealt with equations before. Generally, you would, let's say there's a linear equation, like y equals something. Let's say it was 7x, I don't know, plus 5. All right? And function notation just means that we write this part y equals differently. So it's the way that we write it, the notation, the way we notate this. So f of x instead of y. And the way that I'm saying that f of x is f, and then the word of x. So we're saying f of x equals 7x plus 5. And there's a couple reasons why this way of writing it is more helpful than this. And I'll show you one way. Let's say there was another equation, y equals, let's say, negative 3x minus 4. Just, it could be any equation here. So there's two that are y equals, right? So distinguishing between these two equations, if I said what's y equals down here, you wouldn't know which one I'm talking about. But here, if I say f of x for this one, it's kind of a label, and this one I can label as g of x. Now I can very easily distinguish between the two equations, because I can say the function f of x or g of x, right? So that's one reason why it's helpful. Another reason why it's helpful is a lot of times when we have equations or like little machines, we want to have inputs and where we have inputs and we have outputs, right? So I want to know what happens when x is a specific value. So when I'm plugging in x equals like 5 or 3. Let's try 3. So if I want to plug in x equals 3, I want to know what happens. The way I write it is this, f of 3. And that's how you say it, f of 3 equals. So I'm asking what happens when x equals 3. All right, well, just rewrite the equation. When you see an x, put a 3 there. So there used to be an x there and an x there. So now I'm putting a 3 there. That means I plug in a 3 there. This is probably familiar if you've taken Algebra 1, 2, or any certainly later problems. So then we just evaluate. 7 times 3, that's 21, plus 5, that's 26. So when x equals 3, f of 3 equals 26. So that's the output. That's what the response is, right? And I could do the same thing here with g. I could plug in 3. I won't do that because it's pretty basic. And then the reverse can happen as well. So what happens? What if I want to know what the input is when I'm given the output? So the way you would write that is f of x equals 19. So now I'm saying the output is 19. What's the input, right? So for what value of x do we get 19 when we plug it in? So you would just, what's f of x? 7x plus 5. So this is how you would solve it algebraically. Right? And then you just solve for x. So subtract 5 from both sides. 7x equals 14. Divide both sides by 7. I forgot to put all those little things on my 7s. And x equals, somewhere off the screen, it's 2. All right? So f of 2 equals 19. Pretty simple, right? Nothing too complicated. Well, it can get a little bit more complicated when you start involving graphs. So let's just make sure you remember this thought, I guess. When I'm plugging in a number where the x was, I'm asking what happens to the equation or the graph, what happens when x is 3? So that's a basic question. What happens when x equals 3? Now on a graph, I would want to go to where the x coordinate is 3, and I want to know what the y coordinate is. The y coordinate would be 26. So this would be on the graph, when x is 3, y is 26. Here, when x is 2, y is 19. And that's what that's saying. And you can line that up on a graph. There'll be some practice problems like that later. That's just a basic introduction to function notation.